Imagine we have discovered the room temperature superconductors. In magnetic fields, superconductors can float in the air without energy loss, so we probably can make flying cars just like in the movie The Fifth Element, or the flying broomstick that Harry used for his first Quidditch match. There is another feature of superconductors. Normal conductors have electrical resistance. When electrons collide with lattice atoms, thermal energy is wasted. But superconductors don't have electrical resistance. That means electrons can move without thermal energy loss. So wouldn't it be a good idea to use superconductors to make computer chips like graphic cards, RAM, and CPUs? We could run the most expensive simulations without a single cooler floating in the air. So Google doesn't need these gigantic water tanks to cool down its data center. Nope, it is not a good idea, at least for now. Why not? One of the reasons is that superconductors are too conductive to be used in electronics. You may have heard that computers only understand 0 and 1. In electronics, 0 means a 0 or low voltage, so it's off. 1 means a high voltage and it's on. Here is an analogy. Think about water pipes. Water pressure or the height of water is a voltage. Flowing water is an electric current. That's basically moving electrons. The more pressure, the more water will flow through the pipes. Then what is electrical resistance? The resistance is how narrow the water pipes are. The less resistance, the wider the pipes. However, the electrical resistance is 0 in superconductors. That means the water pipe is infinitely wide. Thus, even a tiny bit of pressure would produce an infinite amount of water flowing. That means a tiny bit of voltage difference in superconductors would produce an infinite electric current, which doesn't make sense. So the voltage across superconductors is always 0, not to make infinite currents. In other words, it cannot receive on signals. It's always off in superconductors. Now we know electronic chips do need electrical resistance. In order to control voltage signals, electrical resistances even need to change dynamically. We need a resistor with transferring resistance, or a transfer resistor in short. Doesn't it sound familiar? Yes, a transistor. In transistor applications, silicon has been the king for decades, and will be for a while, because we can control silicon's resistance easily by mixing impurities in it. Also, it is chemically and mechanically stable like marble. We can carve all the complicated and tiny structures on a silicon wafer, just like how TSMC packed 6.9 billion transistors in my iPhone. The number is almost the population of people on Earth. Can you believe it? Okay, does it mean that room temperature superconductors are useless in electronics? Of course not. It's a revolution. Even minute magnetic fields can be detected using superconductors. For example, human body's magnetic fields. Imagine your smartwatch with superconductors that can do MRI scans to monitor the activity of your brain. And there are many applications aside from that. One of the applications of superconductors in electronics is called superconducting quantum interference device, or SQUID in short. And I will talk about SQUID in upcoming videos, so stay tuned and consider subscribing. Thank you for watching my video.